The launch of the James Webb Space Telescope was more than a technological milestone. It was a turning point in humanity's story. A moment when our gaze into the heavens shifted from wonder into revelation. For as long as we have existed, we've looked to the stars, trying to measure the vastness above us. Every generation of astronomers thought they were close to grasping the true scale of the cosmos. Every generation, humbled, discovered that the universe was larger, older, and stranger than they had imagined. And yet, even after centuries of progress, even after the leap forward that Hubble gave us, our picture of the cosmos was still incomplete. We were seeing only a fraction of the true tapestry. The James Webb Space Telescope was designed to change that, and it did. With its very first major programs, Webb unveiled something staggering, a map of the universe unlike anything ever seen before. One colossal image stitched together with patient precision, containing a record-breaking view of the cosmos. This was the Cosmos Webb Field, the largest, most detailed map of the universe humanity has ever created. Inside that frame, stretching across time and space, lies a catalog of more than 780,000 galaxies. Each a city of stars, each a chapter in cosmic history. And together, they're forcing us to rethink everything we thought we knew about how galaxies form, how stars are born, and how the universe itself evolved in its earliest ages. This isn't just another discovery, it's a rewriting of the universe's opening chapters. To understand the monumental weight of this map, we must first look back at the telescope that carried us here. For decades, our deepest vision of the universe was shaped by the Hubble Space Telescope. In 2004, Hubble captured its most famous image, the ultra-deep field. 11 days of staring into what looked like an empty patch of sky. And from that darkness, it revealed a cosmic zoo. Roughly 10,000 galaxies, some shining from over 13 billion years ago. For the first time, we understood that even the most unremarkable corner of the sky is alive with galaxies. Each point of light, not a star, but an entire galaxy, containing billions of stars of its own. That single image allowed scientists to estimate that the observable universe contained not millions, not billions, but trillions of galaxies. The number rose as high as 2 trillion, a figure so immense it reshaped our sense of scale. But Hubble, as powerful as it was, had limits. It was built to see visible and ultraviolet light, the colors our eyes can see. But the light from the universe's very first galaxies is so ancient, so stretched by the expansion of space itself, that it no longer glows in visible colors. It is shifted into infrared, a spectrum Hubble was not designed to capture. That's why Webb was built. Its golden mirrors, spanning 21 feet, were designed precisely for this mission, to collect the faintest whispers of light stretched across billions of years, to pierce through cosmic dust, to see what Hubble could not. And what Webb has revealed doesn't merely add to the picture, it redraws the boundaries entirely. To put this leap into perspective, if Hubble's ultra-deep field were printed onto a single sheet of paper, then Webb's Cosmos Webb map, at the same resolution, would be a mural stretching over 13 feet wide. The difference is not just scale, it is context. It's as if Hubble gave us a glimpse of a single city block, and Webb has unveiled the entire sprawling metropolis, its neighborhoods, its highways, its surrounding landscape. This unprecedented image was born from one of Webb's largest observing programs, Cosmos Webb. In its first year of operation, over 250 hours of telescope time were dedicated to a single patch of sky. Thousands of exposures were combined into a seamless frame. The result is a map so vast, so detailed, that astronomers will be mining its depths for decades. It contains not just pretty galaxies, it contains history itself. A continuous record of cosmic evolution from a few 100 million years after the Big Bang all the way to the galaxies of today. As we begin our journey into this colossal image, we must remind ourselves of a profound truth. We are not looking at a flat picture. We are looking through time. Every speck of light in this image has been traveling to us across billions of years. The closer galaxies glow with light that left them relatively recently, while the most distant are shining from nearly the beginning of time itself. In the nearby universe, just a few billion light-years away, we see galaxies in their maturity, spirals unfurling their graceful arms, massive ellipticals glowing like ancient embers, irregular galaxies twisting under the pull of gravity. Here, in Webb's broad field of view, we witness how galaxies arrange themselves into grand superstructures, cosmic walls, clusters, and filaments that span hundreds of millions of light-years. In this region, astronomers recently discovered a remarkable object nicknamed the Infinity Galaxy. Two galaxies colliding in such a way that their shapes intertwine into a glowing figure eight. But what makes it extraordinary is not its beauty, but its mystery. Between the colliding galaxies, astronomers detected signs of a new supermassive black hole forming, not inside either galaxy, but in the space between them, a process of black hole birth never seen before. This is the kind of discovery that only becomes possible with a telescope like Webb, capable of surveying such enormous stretches of space.
But as we move deeper into the cosmos Webb field, we travel further back in time, into an epoch astronomers call cosmic noon. About 10 billion years ago, the universe was alive with energy. Stars were forming at the fastest rate in cosmic history. Galaxies here blaze with the light of countless newborn stars. And yet, even in this era of furious creation, Webb has delivered surprises. It has found galaxies that seem quiet, quenched galaxies that have already stopped forming stars, resting in a time when they should have been at their peak of activity. Their silence is a puzzle. Webb has also revealed galaxies with striking spiral structures, arms wound in elegant order, only a few billion years after the Big Bang. Theories had long suggested such orderly forms would take much longer to appear, and yet, there they are. This tells us that galaxies were assembling, organizing, and evolving far faster than our models predicted. And now, we arrive at the very edge of vision, the cosmic dawn, a time only a few 100 million years after the Big Bang, the very first era when stars and galaxies began to ignite. Before Webb, models predicted this epoch would be sparse. Galaxies should have been tiny, dim, primitive. The universe should have needed more time to gather matter and kindle the first stars. But what Webb has shown is something profoundly different. The cosmic dawn is crowded. Bright galaxies abound where we expected darkness. Record after record has fallen. First came Glass Z14, a galaxy shining only 290 million years after the Big Bang. Then came another, even more distant MAISEI Z14, existing just 280 million years after the universe began. And these are not primitive smudges of gas. They are already luminous, structured, and enriched with heavier elements like carbon and nitrogen. That means that at least one entire generation of stars had already lived, died, and seeded their galaxies with new elements, all within the first 300 million years. This is almost impossibly fast, and it challenges the very foundations of our cosmological models. The implications are staggering. We thought we understood the universe's timeline. First the Big Bang, then hundreds of millions of years of darkness, then the slow rise of the first stars, and much later the growth of large galaxies. But what Webb has shown us is something profoundly different. The cosmic dawn is not a quiet, empty void waiting patiently for creation. It was busy, active, productive. Galaxies were forming stars, building structure, and evolving with astonishing speed. This forces scientists back to the drawing board. Our models of galaxy formation, the birth of supermassive black holes, even our understanding of how quickly the universe could produce complex elements, all of it must be rethought. So what is the true scale of the universe as revealed by Webb? On one level, it is a number, 780,000 galaxies in a single patch of sky. And each galaxy contains billions of stars, and each star may host worlds of its own. The scale is beyond comprehension. But on a deeper level, the scale is a shift in perspective. The realization that the universe is not only larger than we thought, but far more complex, structured, and mature at its earliest ages than we ever dared imagine. It is humbling, it is unsettling, and it is exhilarating. Because this is what it feels like when the scale of your world changes, when a single image redraws the boundaries of existence. For the first time, we are not seeing faint smudges at the edge of time. We are seeing entire populations of early galaxies, bright, structured, demanding explanation. And perhaps the most awe-inspiring truth of all is this: even this colossal map, the largest we have ever made, is still only a tiny window into the whole, just one frame in an infinite tapestry. The James Webb Space Telescope has given us a new vista, a truer scale of the cosmos, and with it we are reminded of a timeless lesson. The universe will always be deeper, richer, and stranger than we think. Don't forget to subscribe for more space content.